Hi everyone, my name is Lahiru and my student ID is 10507251. Today I'm gonna demonstrate about TCP IP. First of all, we're gonna figure out what is the TCP. TCP IP, or the Transmission Control Protocol, Internet Protocol, is a suite of communication protocols used to interconnect network devices on the Internet. TCP IP can also be used as a communications protocol in a private network, an Internet or an extranet. The entire Internet Protocol suite, a set of rules and procedures, is commonly referred to as TCP IP, though others are included in the suite. TCP IP specifies how data is exchanged over the Internet by providing end-to-end communications that identify how it should be broken into packets. Address transmitted, routed and received at the destination. TCP IP requires little central management, and it is designed to make network reliable, with the ability to recover automatically from the failure of any device on the network. The two main protocols in the Internet protocol suite serve specific functions. TCP defines how application can create channels of communication across a network. It also manages how a message is assembled into smaller packets before they are then transmitted over the Internet and reassembled in the right order at the destination address. IP defines how to address and route each packet to make sure it reaches the right destination. Each gateway computer on the network checks the IP address to determine where to forward the message. This is how TCP IP works. TCP IP uses the client-server model of communication, which a user of machine. A client provided a service like sending a web page by another computer, a server in the network. Collectively, in the TCP IP suite of protocol is classified as stateless, which means each client request is considered new because it is unrelated to previous requests. Being stateless free up network path so they can be used continuously. The transport layer itself, however, is stateful. It transmits a single message and its connection remains in place until all the packets in a message have you received and reassembled at the destination. The TCP IP model differs slightly from the 7-layer open system interconnection OSI networking model designed after it, which defines how applications can communicate over a network. Then we can capture some TCP IP traffics. I'm going to first open my web browser, and after opening I'm going to browse a website. Yeah, the website is already loaded, and then I'm going to open the wireshark capturing software. Now the wireshark software is loading. Then I'm going to select Wi-Fi from here and open. In here you can see a lot of packets appearing here, and then I'm going to stop the capturing, and from here we can see the frame Ethernet like interface ID appearing here, and the encapsulation type Ethernet 1, arrival time, time shift for this packet, interface ID details, and the Ethernet ISRC, destination broadcast address here, and the source type and the padding. From here, internet protocol version is 4, and the source address there, and the total length, identification, flags, time to use, and the protocol UDP. In the all the way down we can see use diagram protocol, source port, and the destination port, length, and the stream index like details appearing in here. And bottom of this layer, this data 12 bytes, data length, like a lot of details we can see here. Now I'm gonna filter the specific one, TCP, and press the enter. Now we can see another lot of packets here appearing. The same way the application data, like the frame, interface ID, then another interface name for the specific TCP, and the time delta previous captured, Ethernet source. In here appearing its internet protocol version, and the transmission control protocol, source port, destination, and here in the bottom, transport layer security. In this menu we can see the record layer, application data protocol, HTTP over TLS. Like that, we can use this wireshark software to capture the TCP in here. And thank you.